In this video, we're going to be looking at characteristics of rational functions, in particular the domain, intercepts, and asymptotes. So a rational function is one that you can write as a rational expression. So it'll have a numerator and a denominator. And the numerator and denominator will be polynomial functions. And of course, the denominator is not allowed to be 0. So think of a rational function as a fraction where the numerator is a polynomial and the denominator is a polynomial. So we have a concept of what domain and x and y intercepts are from Math 100. With asymptotes, there's two types. There's vertical asymptotes and horizontal asymptotes. Vertical asymptote is a vertical line, and notice here that they're drawn in a different color because they are not part of the graph. They're not part of the function. It's a vertical line that the graph approaches but never touches. So with vertical asymptotes, that is always the case. They will never be breached. And you can see in here, they get closer and closer and closer, but they will never touch. And in this particular picture, you can read off what the vertical asymptotes are. This is a vertical line, and it goes through -3 on the x-axis, so its equation is x equals -3. So we did vertical and horizontal lines in Math 100. And this vertical line has the equation, well, it goes through 2 on the x-axis, and it has the equation x equals 2. So it's wrong to say that the vertical asymptotes are -3 and 2. That's wrong. They're lines, and as such, lines have equations. Those are just numbers, not equations. Now, a horizontal asymptote is a horizontal line that a graph approaches, and it may or may not breach it. So in this example down here, this red line is a horizontal asymptote, and you can see that the graph is approaching it, but it will never breach it. Now, other times, you can have a horizontal asymptote, and the graph does breach it, but we can see, like if we're coming here, it's getting closer and closer and will never breach. Now here, it's true we do have a breach, but after a certain point, after we're here, it engages in the behavior where it settles in and it approaches, and it will never breach. So as you go from negative to positive infinity at the extreme left and right, it's not breaching. Okay. So characteristics of rational functions, they all have a y-intercept. Well, sorry, if it exists. So they may or may not have one, but it's an easy thing to calculate what it is if it exists. So if we have a rational function r of x, then our y-intercept is found at r evaluated at 0. And the y-intercept is a point, and so its coordinates are 0, r of 0. The domain is the set of allowable x values, and make sure you figure out what the domain is before any cancellation. So do not cancel when you're trying to work out the domain. If there are any cancellations, do not make them. Now, when it comes to x-intercept and vertical asymptotes, those are found after cancellation. In particular, any x-intercepts, if they exist, are found at the real zeros of the numerator and the real zeros of the denominator after any cancellation. So we're only going to be looking at real zeros. Okay. Now, with horizontal asymptotes, how do we find them? Well, we have 3 cases. So suppose our rational function, and actually I'll call it r of x instead of f of x. So suppose we have a rational function and we have the numerator over the denominator. If the degree of the numerator is smaller than the degree of the denominator, then our function r does have a horizontal asymptote, and it's the x-axis. And its equation is y equals 0. So let me change these to r's. If the degree of the numerator and the degree of the denominator are the same, we will have a horizontal asymptote, and its equation will be y equals a fraction with the leading coefficient of the numerator in the top and the leading coefficient of the denominator in the bottom. And you want to put that in lowest form. So if you had something like y equals 2/4, you would reduce that because the answer would be y equals a half. Okay, you wouldn't leave it like that. So that's what it means in lowest terms or in lowest form. Now, if the degree of the numerator is bigger than the degree of the denominator, you don't have a horizontal asymptote. So for all of the questions in this lab, you want to determine the following. So A, B, C, D, E, F, G, all of these questions, all of these examples will find the same thing. The first thing is you want the factored form, if it can be factored and you don't do any cancellation. The second thing is the y-intercept, then the domain, then the x-intercepts and vertical asymptotes, then the horizontal asymptotes, and then sketch the graph. Now, sketch the graph, that means you can use your calculator to look at the graph, but from the information that you've gotten from A through F, you should be able to get the right viewing window and be able to make a good sketch using your graphing calculator, but also what you found out from A through F. So let's look at our first example. Let's come down here. All right, so suppose r of x is equal to 3x plus 2 over 7x minus 4. That cannot be factored further. Okay, there's nothing, it's linear. 3 and 2 don't have anything in common. There's nothing I can factor out. Same for the denominator, so that's as far as it can go. Now, what is the y-intercept? Well, like we said up before, the y-intercept is found by evaluating your function at 0. And so if I evaluate the function at 0, everywhere there's an x, I replace it with 0 in parentheses. And I'm going to be left with the number 2 over negative 4, which will be negative 2/4, which simplifies to negative 1/2. So we have a y-intercept, and its point has coordinate 0, negative 1/2. Now, what about the domain? So C is the domain. The denominator is never allowed to be 0. So if we're looking for the domain, the denominator is not allowed to be 0, but you have to get the restriction on x. This is telling you what 7x minus 4 is not allowed to be. So let's add 4 to both sides. And then let's divide both sides by 7. And this gives me my restriction on x. X can be any real number as long as it's not 4/7. So, as a sentence, the domain is any real number except 4/7. The domain is the set of allowable x values. So in interval form, it would be this. On a number line, you would not allow 4/7, but you would allow anything to the left or the right. And if I write this from left to right, this is how we get our interval form. In set notation, it would be x is any real number as long as x is not equal to 4/7. Most of the time in WebWorks, they'll want you to give your answer in interval form. So again, Math 100, we had lots of interval notation for answers. Now, in part D, we were asked for the x-intercepts. So x-intercepts are found at zeros of the numerator. So if I set the numerator equal to 0 and solve for x, what do we get? Subtract 2 from both sides. Divide both sides by 3. So I have an x-intercept at negative 2/3. So an x-intercept is a point, and its coordinates are negative 2/3, 0. Now, part E asks for the vertical asymptotes. Vertical asymptotes are found at the real zeros of the denominator after any cancellation. Of course, there wasn't any cancellation here. So if I set that equal to 0, add 4 to both sides, and then divide both sides by 7, I get the equation of the vertical asymptote. And there is one vertical asymptote, and it is the line x equals 4/7. And finally, is there a horizontal asymptote? Well, what is the degree of that? What's the highest power of x? The highest power of x is 1. So the numerator has degree 1. And what's the highest power of x in the denominator? It's 1. So the denominator has degree 1. So I'm in the case where numerator and denominator have the same degree. So if the numerator and the denominator have the same degree, then I'm in this case, and it's going to be y is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. That will be the equation of my horizontal asymptote. And so here we can see my leading coefficient of the numerator is 3. And my leading coefficient of the denominator is 7. So that is the equation. Remember, a horizontal line has an equation y equals. That is the equation of my horizontal asymptote. And so it's going to be the line that goes through 3/7 on the y-axis. Now, how do we draw a sketch of this? Well, you'd want to put it in your calculator. So what you would do is you would come here, clear out anything, make sure your plots are off. If they're highlighted, then they're on. So if you scroll up to them and press enter, and then scroll back here, your plot should be off. So none of these should be highlighted. Now, with this rational expression, there is in Canvas, there is a PDF called How to Enter Web Work Answers. And it gives you this chart of what to type. So when we come down here, you can see what do you type to put in these mathematical expressions. Basically, if your numerator or your denominator has more than one term, you have to put grouping symbols around it. So let's now go back to our calculator. So if you have an older version calculator, or if I was going to type this into WebWork, then the numerator has more than one term, as does the denominator, and you'd have to type in that. So that's what I'm going to do for this. So in parentheses, 3x plus 2, otherwise you're going to get the wrong function, divided by 7x minus 4. Now I always start with a zoom 6. A zoom 6 gives you a standard window, and the x and y axes go from -10 to 10. Now, as you can see, that's really not giving me the best picture. Now, I'm going to refine this window, and the way I'm going to refine this window is I've determined that there's a y-intercept at -1/2 and an x-intercept at -2/3. And I have a vertical asymptote at x equals 4/7 and a horizontal asymptote at y equals 3/7. So I can adjust this window. Instead of -10 to +10, I could do -5 to +5, and that might be better for this. Let me press graph. I'm still not, like, you can see where I'd expect the x-intercept and y-intercept to go. I might just adjust this y minimum, say, to -2 to +2. That's giving me a better picture. Now, again, if you have this older model, they give everything all in one color. You must understand that asymptotes are not part of your function. So this asymptote here aligns with what we predicted, a vertical asymptote of x equals 4/7. So 4/7 is between 0 and 1, and it's closer to 1 than it is 0. So that's verified. Also, we said that we had a y-intercept at -1/2. That looks to be where that's happening, that there would be an x-intercept at -2/3. Certainly from the grid marks, that's proving to be correct. And a horizontal asymptote at y equals 3/7. And so that's going to be well between 0 and 1, a little bit closer to 0. So about there, that is in line with what we've predicted. And you can see down here, I've drawn that. And that is conforming to what we have, and I've chosen the right window to show everything. And so this would be a good sketch. So I would take my pen and I would try and draw in this free-handed, so we can see that it's approaching, but it's not going to touch. Same kind of thing here. So this would be a good sketch that we could make for what the graph looks like. So I put everything together, I get the correct viewing window, and use my graphing calculator. So I just don't automatically do zoom 6 for everything and then try and graph that, because not every graph is suited to zoom 6, which is -10 to 10 for the x and y axes for their min and max. Okay, so now that we've gone through the first one, let's see how we would be at the second. So again, we are wanting to find the same thing with every problem. We want the factored form, the y-intercept, the domain, the x-intercepts, if any vertical asymptotes, any horizontal asymptotes, and then to sketch the graph. Okay, so now this has a capital F. That's okay. Answer, well, there's more than 5. 1, 2, 3, 4, 5, 6, 7. Answer the above questions for this function. Okay, so again, what we're going to have to do here with this one, we're going to need, to get it into factored form, you're going to have to factor the numerator and the denominator separately. Okay, so with this one, the denominator is the easier one to factor. Two numbers that multiply together to give you -10, but at the same time add up together to give you -3, and that would be -5 and +2, and so you would factor that as x minus 5, and x plus 2, as we have here. And this is part of your factor review of your first lab. And similarly, I want my product to be negative 42, and I want my sum to be positive 19. And 21 and 2, yes, if I've got 21 and negative 2, that should work. So 21 times negative 2 is negative 42, and 21 plus negative 2 is positive 19. Okay, so they have a 3 in common and an x in common. So that leaves me with a 2x plus 7, and then these have a negative sign in common, and so if I factor it out, I get that. And so I'm going to have a 2x plus 7 in common, and then what goes in here? 3x minus 1, and which is what we have there. Okay, so that part is a review of Math 100 factoring. And really, I took up a lot of time in this video doing something that you should already know how to do. So that is the factored form. There is no cancellation, and if there was cancellation, you wouldn't make it. Now, to find the y-intercept, you find it at evaluating the function at 0. So wherever there's an x, you replace it with 0, which I'm going to do in the original form because these terms quickly go away. And you're left with negative 7 over negative 10. The negative signs cancel, and you're left with positive 7/10. And so that's where my y-intercept is. Now, for part C, we want the domain. Now, for the domain, you're going to look at the factored form, and you can clearly see what's not allowed. X is not allowed to be 5, and x is not allowed to be negative 2. Because if x is equal to 5, it makes the bottom 0, and you're not allowed that. If x is equal to negative 2, the bottom is 0, and you're not allowed that. So I can write it in set notation form, which is x can be any real number as long as it's not negative 2 or 5. Or you can do it in interval notation. So how do you write it in interval notation? Well, you look at the number line, and you find 5 and negative 2. And x is allowed to be anything except 5 or negative 2. So it's anything else on the line. And reading this from left to right, you're starting at negative infinity, coming up to negative 2, but then there's a gap, you have to jump over it. Then you want everything between negative 2 and 5, which is this interval. Then you jump over that, and everything beyond 5. All of this was done in Math 100. So again, there's a lot of stuff in here that depends on your assumed knowledge. Either form is fine. Now, if x-intercepts exist, they're found at the real zeros of the numerator after any cancellation. There's not any cancellation. Now, for x-intercepts, where are the zeros? Well, the zeros happen when either factor is equal to 0. But you have to have that in terms of what x can be. So here, add 1 to both sides, then divide both sides by 3. So you have a 0 at x is a third, and you also have a 0 at, well, subtract 7 from both sides and divide both sides by 2. So you have 2 zeros. The zeros of the numerator are 1/3 and negative 7/2. So we'll have 2 x-intercepts, and they're 2 points, and you write them as points. So their x coordinates are 1/3 and -7/2, and their y coordinates are 0. Now, what about vertical asymptotes? Well, vertical asymptotes are found at the real zeros of the denominator after any cancellation. There's no cancellation here, so the zeros of the denominator are 5 and -2. That's what makes the denominator equal to 0. So I have two vertical asymptotes. They are vertical lines, and so they have equations. And the equations of vertical lines are x equals 5 and x equals -2. Now, what about any horizontal asymptotes? Well, what is the degree of the numerator? It's the highest power of x. So the degree of the numerator is 2. The degree of the denominator is also 2. So back on the previous page, you had 3 cases of what to do with horizontal asymptotes. If the degree of the numerator is equal to the degree of the denominator, then you do have a horizontal asymptote. And so the horizontal asymptote is going to be y equals the leading coefficient of the numerator, which is 6, divided by the leading coefficient of the denominator, which here is understood to be 1. But of course, 6 over 1 simplifies to 6. So my horizontal asymptote is y equals 6. Now, I want to graph this. So if I'm going to graph this, I'm going to put the original form into my calculator. Just remember, you have more than one term in numerator and denominator, so I'm going to need to put parentheses. So I'm going to have 6x squared plus 19x minus 7, all divided by x squared minus 3x minus 10. And I'm going to start with a zoom 6. Okay, now the thing about vertical asymptotes that you have to remember is there is always something of the graph to the left and to the right. And this viewing window is not giving you the complete picture. So you have a vertical asymptote here, and you have a vertical asymptote here. You do not, sorry, we have part of the graph here. I'm just trying to do this freehand. And we have a section of graph here. But there's nothing showing up on this side. And that does not mean that there's nothing there. That means that you haven't chosen a proper window to see what's there. So if I'm going to sketch this, I need to change my window. And I might just, since I'm looking for a missing piece to the right, let's see what happens if I make my X max into a 20. Will I get all the pieces there? Okay, I am getting a piece there, and also I'm going to, I might change that from -5 and then bring my Y max up to 20, then press graph. Okay, this is a much better picture, I think. And let me see what I chose down here. Yeah, that is what I chose. Let me get this back up there. And I can see I had a y-intercept at 0,7/10. So it's very close to +2. So we should be able to see that. That we had x-intercepts at 1/3, 0, which would be about there, and -7/2, 0, which would be around there. So that's being shown. We would have vertical asymptotes, x is equal to 5 and x is equal to -2. So there's my one at x equals -2. And at x equals 5, that's going to be about there, because you can tell that the graph is going to keep going up like that. And then we have our horizontal asymptote, which is y is equal to 6. And if we find 6 on this graph, it's going to be about here. And again, you can tell the behavior is going to be towards positive infinity and towards negative infinity. And so that is a good window to take all of your, to graph it in. And so that's what I've done down here. And again, I've put the asymptotes in different colors because they are not officially part of the graph. And you should be able to see your y-intercept and your x-intercepts. There should be enough detail where you can see that. So that's how I use my graphing calculator to do that. So again, so answer the above questions for this function. Okay. So in the factored form, well, in Math 100, x squared minus a number is x minus the square root of that number times x plus the square root of that number. Okay. That was one of the rules for factoring. This, well, what do they have in common? They have a 5 in common. And after factoring, we have an x plus 6. So this is the factored form. Do not cancel. This is the factored form. Now, what is the y-intercept? So the y-intercept, we evaluate our rational function at 0. So wherever there's an x, we replace it with 0. So that's going to go away, and I'm going to get -36 over 30. But of course, that reduces. It reduces. 36 is 6 times 6, and 30 is 5 times 6. So the 6's cancel, and you get -6/5. Or you can always use your calculator to get something in lowest form. So let me get out of here. And if I wanted to reduce -36 over 30, press enter twice. So enter, enter. Oh, no, sorry, don't press. I just press enter, then press math, then press enter twice. Enter, enter. And that gives me the lowest form. Okay, so let's try that again. -36 over 30. Enter, then press math, then enter twice. Enter, enter. And it gives me the lowest form. You would never see an answer written like that. That is not in lowest form. So any kind of multiple choice selection, it would look like that. So the y-intercept has those coordinates. Okay, so the next thing they want is the domain. Now, when it's in factored form, so we're here on domain. When it's in factored form, look at what's allowed. With a fraction, you're not allowed to have 0 on the bottom. So look at the denominator. That is not allowed to be 0. Divide both sides by 5. 0 divided by 5 is just 0. So in particular, x plus 6 is not allowed to be 0. You want the restriction on x. And now how do I get x by itself here? I subtract 6 from both sides. So the restriction on the domain is x is not allowed to be -6. The domain is the set of what x is allowed to be. So x can be anything as long as it's not -6. So that's in set notation, but more often than not, in WebWorks and in the multiple choice selections on finals, you're asked to give it in interval form. So on the interval, on the number line, x is not allowed to be -6, but it can be anything else. And so if you were to describe the numbers in red going from left to right, well, you're coming in from -infinity up to but not including -6, so you have to jump over, and then everything to the right of -6. In WebWork, you'll have to use INF for infinity, or sometimes they'll tell you to write infinity in the entire word. Now, the next thing they want is the x-intercepts and vertical asymptotes. So with x-intercepts and vertical asymptotes, this is after cancellation. Now you go and cancel. So after cancellation, you have x minus 6 over 5. So for x-intercepts, you're looking at zeros of the numerator after cancellation. So a 0 of the numerator is 6. So we have one x-intercept, and it is the point 6, 0. Only one. Now, what about the vertical asymptotes? Vertical asymptotes are found at the real zeros of the denominator after cancellation. Well, after cancellation, we have this, and the denominator doesn't have any zeros because the denominator is just the number 5. And it doesn't matter what x is, it will always be the number 5. So we don't have any vertical asymptotes. And then finally, what about horizontal asymptotes? Well, the degree of the numerator is 2, and the degree of the denominator is 1. So the degree of the numerator here is bigger than the degree of the denominator. And from the first page of the 3 cases, if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. So this is a situation where we don't have any vertical or horizontal asymptotes. And when we graph this, and I'll graph the original one, so let me come here and get rid of it. So in parentheses, x squared minus 6 all over 5x plus 30 if I start with a zoom 6, I get that. So let me go back here. X squared minus 36, my bad. I'm trying to do this with a mouse, and it doesn't always respond to my clicks. 5x plus 30. Okay, let me try that again. And I'll do a zoom 6. Okay, and in this standard viewing window, I think there's a lot of y-axis that I'm not seeing. So I'm going to press window, and I'm just going to change the y. Instead of -10 to +10, how about, say, -5 to +5? And let's see if that gives us a better view. Okay. So there is no vertical asymptote. There is no horizontal asymptote. We said that we had a y-intercept at 0, negative 6/5, so that's just a little bit below -1. That's checking out. And we said that there was an x-intercept at 6, 0. That looks to be definitely what's going on there. And that really is all there is to show, since there aren't any asymptotes of any kind. Okay, so here's how we would draw that one. Okay, and let's answer the above questions for this one. All right, let's see what we can do with this one. Well, first of all, we need to factor it. So the numerator, they have a 3 in common, so I can factor that out. And the denominator, two numbers that multiply together to give me -10, but add up together to give me -3. Again, that would be -5 and +2. Now, do not cancel. Do not cancel, as it says. You want to leave it like this when you're going to find the domain. Now, the y-intercept, you just evaluate that at 0, and I would evaluate the original one. If you evaluate the original one at 0, everywhere there's an x, you replace it with 0. Then you're left with -15 over -10. The negative signs cancel, in lowest form, that's 3/2. So we have a y-intercept, and it's at 0, 3/2. Now, if I'm going to find the domain, you look at this before any cancellation, and you can see with the domain is what x is allowed to be, and we can see here that x is not allowed to be 5, and it's not allowed to be -2. And so you can either write it like that, or you can put it in interval form. Now, for x-intercepts and vertical asymptotes, we want to look at real zeros after any cancellation. So now, after cancellation, we're left with 3 over x plus 2. All right, that's where we're getting this. So the numerator has no x values. The numerator will always be 3, no matter what x is. And so the numerator has no real zeros. There are no x-intercepts. Now, what about the denominator? Well, we can see that the denominator has a 0 of -2. If x is -2, it will make the denominator 0. So we do have one vertical asymptote. Its equation, since it's a vertical line, is x equals -2. Now, what about any horizontal asymptotes? Well, the degree of the numerator is 1. The degree of the denominator is 2. So the degree of our numerator is smaller than the degree of our denominator. And so for those 3 rules on the very first page, that means there is a horizontal asymptote, and it's the x-axis, which has equation y equals 0, if we're in that case. Okay, so now we have enough to graph it. And if we're going to sketch it, we want to use our graphing calculator, but also we want to choose the best window for it. So I'm going to have 3x minus 15 in the numerator divided by x squared minus 3x minus 10 in the denominator. And I'm going to start with a zoom 6. Okay, this is actually looking pretty good in the window that it's in, because we can see that we did have a vertical asymptote with the equation x equals -2, and there it is. So vertical asymptote has equation x equals -2. And we had that the x-axis is in itself a horizontal asymptote, and I hope we can see that that's exactly what's going on there. And so the x-axis itself is a horizontal asymptote. We can confirm that there's a y-intercept at 0,3/2, which is 1.5, which is right between 1 and 2. That fits. And that there are no x-intercepts. That is what's happening because this is approaching but never reaching the horizontal asymptote, which is our x-axis. And so that has everything in that drawing, and that's a good window for it. Okay, so this is what we have here for the window. Okay. All right, so that gives us an example of just about every type. Okay. Is it possible that you do not have a y-intercept? That could happen if you had. Well, let me do another one. Let me do an example 5. Just make it a little bit oops. If I had something like this, and we were asked what is the y-intercept? Well, what happens when we evaluate at h of 0? It's going to be equal to well, in the top we would have 3 times 0 minus 15, and in the bottom we'd have 0 cubed minus 3 times 0 squared minus 10 times 0. And that would equal, well, in the top we'd have negative 15, and in the bottom we'd have 0. And that does not exist. Thus, there is no y-intercept. So the rest of the things would be pretty easy to come because you just use example 4 in your factoring. So I'm going to leave that one in there, and I'll work them all out for you, but I'll let you go through those on your own and see what you get with that. Okay, so I'm going to stop this video, and should have enough now to do your web work.